The telescope captured the object changing its trajectory in an unnatural manner, meaning it must be some sort of extraterrestrial light.
8 deep space radio signals were detected by an AI system in 2023 that met all the requirements scientists have for extraterrestrial technology, and it was powered by Google's AI tools. These weren't only isolated occurrences amid the cosmic cacophony. Only when telescopes directed at particular star systems did the exact narrow band signals become visible. The fact that these signals had gone entirely unnoticed in thousands of hours of earlier research using conventional techniques is what really sets this discovery apart. It wasn't until artificial intelligence combed through 150 gigabytes of data that the signals were discovered. That's more than 30,000 HD films, and it saw things that human astronomers had missed. One of the most significant advances in our quest for proof that we might not be alone in the cosmos is this discovery. What is the significance of these signals? There are particular standards that scientists use to determine what could be considered an alien signal, and these signals met all the requirements. At first, they only showed up when radio telescopes were focused straight at particular stars. When the telescope was pointed away, they vanished entirely. Instead of local interference, this on-off pattern is just what you would anticipate from a distant transmission source. Secondly, these signals had a limited bandwidth of only a few hertz, which is simply not produced by normal cosmic processes. Broad waves of all spectrums are produced by galaxies, pulsars, and stars. However, the laser-like focus of these signals suggested intelligent design. Third, they showed Doppler drift, which is a small change in frequency that suggests a moving source, such as a transmitter on a planet that rotates. The ultimate goal of SETI research is this triple combination. Humans weren't the only ones who made the discovery. To re-examine data from the Breakthrough Listen project, Peter Ma, a student at the University of Toronto, created a deep learning system based on Google's TensorFlow technology. The AI discovered exactly what conventional algorithms were unable to detect: possible technological indicators that fit our theoretical description of extraterrestrial communication. What this AI discovered next, however, is even more perplexing. In our quest for extraterrestrial intelligence, the 8 signals were only the start of a revolution in artificial intelligence. Then, years of astronomical data that had previously been thought to have been thoroughly examined were reanalyzed using the same neural network architecture. The AI model's discovery of signals that had been entirely overlooked in a 2017 scan of 150 TB of data from scans of 820 neighboring stars was the most startling discovery. These AI models are currently being used by researchers from the Breakthrough Listen project, one of humanity's most ambitious attempts to find extraterrestrial civilizations, to categorize and rediscover signals that were previously written off as meaningless noise. We are now flagging patterns that were previously undetectable for more research. Nothing less than a paradigm change is taking place. The limits of SETI are being redefined by AI's capacity to detect what humans overlook. We have been using human-designed algorithms to search the universe for decades, but these may have been excessively strict or constrained. We're allowing AI to see the world from a different perspective now, and it's revealing things we didn't know existed. Please remember to subscribe if you think these discoveries are incredible. Every week, we present to you the tales that science has yet to complete: the cosmic haystack versus AI. It's been said that locating proof of extraterrestrial intelligence is like trying to discover a needle in a cosmic haystack. However, we have no idea what the needle looks like. AI technologies have completely modified this situation. To sort through the proprieties of radio telescope data, SETI researchers today employ advanced machine learning models built on the Google and NVIDIA frameworks. That's millions of megabytes searching for the smallest star whisper. Not only are these neural networks quicker than human analysts, their approaches to the issue are essentially different. AI is able to spot tiny correlations and abnormalities that don't fit any known template, whereas traditional algorithms search for particular predetermined patterns. The systems can separate real cosmic signals with previously unheard-of precision by filtering out Earth-based interference from satellites, radar, and cell phones. Real-time analytic capabilities that were unthinkable only a few years ago have been made possible by the CD Institute's direct integration of these AI tools into their radio telescope operations. Large volumes of data pass through these models every second, and as they search for technological signs, each model learns and gets better. Cherry Ang, an astronomer at the University of Toronto, who developed the AI system that identified those 8 signals, expressed it succinctly. We're not claiming that they are extraterrestrials, but we can now more accurately assess the likelihood. The team admits that the signals were not seen again during follow-up observations, which is essential for confirmation. However, the initial finding shows how AI may transform the search. Is AI our best chance of discovering extraterrestrial life? Before we unveil what Google's AI might discover next, please share your thoughts in the comments below. Is it possible for AI to recognize extraterrestrial AI? The intriguing notion put out by Harvard astronomer Avi Loeb completely changes our understanding of what we're looking for. What if highly developed extraterrestrial societies have already transcended biological forms? According to Loeb, if aliens are real, they may have evolved into machine intelligences long ago. Basically, their own ADA. This goes beyond speculative science fiction. Martin Rees, the Astronomer Royal of the United Kingdom, has echoed this sentiment, speculating that we may be looking for electronic descendants of biological organisms rather than entities made of flesh and blood. According to Rees, any aliens we ever come across will be electrical intelligences rather than organic beings like us. Consider it. In just a few decades, our own AI systems have significantly improved. It's possible that a culture thousands or millions of years before us developed artificial minds that are considerably more complex than we can imagine. Minds that wouldn't be constrained by our delicate biological needs and could withstand the harsh conditions of interstellar space. This opens up a fascinating potential. One day, our AI may be able to decipher signals from another AI society. We might be creating the exact instruments required to speak with extraterrestrial machines. Instead of being only tools, Google's DeepMind and Gemini AI systems are currently being created as scientific partners. They assist in creating hypotheses and designing experiments in addition to processing data. In the end, the hunt for extraterrestrial intelligence may turn into a dialogue between our own intelligence and that of species orbiting far-off stars. One of the most likely ways to realize we're not alone is through this AI to AI first contact scenario, which is already happening. New discoveries made possible by Google AOI, Google's AI has pushed the bounds of space exploration in more than just the quest for extraterrestrial communications. Google's artificial intelligence garnered media attention in 2017 when it assisted NASA in finding Kepler-90I, an 8th planet around a far-off star. This discovery was important because it linked the number of planets in that solar system to that of our own. In the same data, the AG discovered something that human astronomers had overlooked. Chris Chalou, an AI engineer at Google, assisted in training a neural network to identify the minute transit patterns of planets passing in front of their stars. Patterns that are too subtle for accurate detection using traditional techniques. Tiny brightness dips, which happen when a planet moves in front of its star and blocks a very small portion of its light, were detected by the system. A 2019 partnership between Google and the University of Texas at Austin built on this achievement by using comparable AI methods to find 2 additional exoplanets that had been entirely overlooked in Kepler's extended mission data. Before machine learning exposed them, these worlds had been hidden in the background, undetectable. In 2018, perhaps most impressively, 72 concealed rapid radio bursts from a recurrent source were detected using Google's TensorFlow. In real time, scientists had discovered 21 flashes from this enigmatic cosmic object. However, in the same data set, the AI system found over 3 times as many. Researchers dubbed FRB 121102 the richest data set they had ever encountered as a result of this discovery. What happens if AI starts to drive research instead of just supporting it? We are seeing the beginnings of a revolution in which robots do more than simply calculate numbers. They are the ones who detect patterns that are too delicate for humans to see. The most enigmatic signals to yet. Even more advanced AI systems are already searching the skies around the clock for proof that we're not alone, even though the 8 signals from 2023 made headlines. One of the most potent radio observatories on Earth, the extremely large array in New Mexico, has been enhanced with what scientists refer to as an AI sidecar that analyzes an incredible 2 terab of data per second in real time. That would be the same as 500 HD movies being downloaded at once and instantly processed by machine learning systems. These devices search for more than simply the narrow band transmissions that have been the focus of classic SETI. They are designed to detect abnormalities, odd patterns, and wideband bursts that would have been dismissed as noise by earlier techniques. The artificial intelligence doesn't assume that alien technology should appear like this. It merely highlights anything that doesn't align with established natural occurrences. According to SEI Institute CEO Bill Diamond, these AI systems are essential for contemporary searches. Nowadays, there is so much data that no human team could ever review it all. The Breakthrough Listen project is rapidly expanding, with plans to use AI to scan 1 million stars using South Africa's Meerkat radio telescope array in the upcoming years. Diamond explains, AI doesn't get tired, doesn't miss things because it's been staring at screens for too long and can spot patterns humans might never recognize. Compared to earlier polls, this indicates a 1,000-fold rise. The neural networks will create the most thorough search for technoscience in human history by processing more radio frequency data than all of the earlier SETI projects combined. These systems continuously improve their capacity to distinguish the genuinely unique from the cosmic backdrop by learning from each observation. These AI signals are our best chance of spotting any signal out there, even if it's one we didn't think to search for, separating viral hype from actual science. It's important to distinguish real scientific discoveries from sensationalized claims amid all of the enthusiasm surrounding artificial intelligence and the hunt for evidence of extraterrestrial life. The rumor went popular on social media earlier this year, claiming that Google's quantum AI discovered Planet 9 using the James Webb Space Telescope. Here's the truth, though. This was wholly untrue. In the actual Planet 9 candidate research, historical infrared sky scans from 1983 and 2006 were analyzed. Not the Webb telescope or Google's AI, but the IRIS and ACRI missions. 2 little spots that could point to a giant planet in the outer solar system were found by astronomers in these datasets, which were separated by 23 years. However, the evidence is still disputed and inconclusive. The participating scientists have been transparent. These weak signals can just be coincidental artifacts in the data or random noise. This trend recurs in many dramatic claims regarding AI breakthroughs in space. As one researcher stated, we need much more observational evidence before we can claim anything with confidence. Until it hardly resembles the real science, a kernel of valid study is warped and overblown. Do you recall the 8 radio signals we covered earlier? Even if those star systems were truly intriguing and did need more research, scientists promptly reobserved them and discovered no repeat communications, an important step in verifying possible alien technology signatures. This is an important lesson. Although AI is very good at identifying patterns and anomalies in large datasets, it is not always able to verify the meaning of those patterns. It is a strong detector rather than a conclusive interpreter. Before we can make any judgments, every possible discovery, whether it's a new planet, an odd radio signal, or an odd spectral signature, must pass stringent scientific verification. The last condition of verified, repeatable proof of extraterrestrial life or technology has not yet been met by any of the AI-detected contenders. However, that doesn't lessen the revolution in our search methodology. It serves as a reminder that extraordinary claims necessitate extraordinary proof. The UAPUFO controversy and AI. The discussion around strange objects in our skies attained previously unheard of levels of public attention in 2023. Former CIA official David Grouch made news when he testified that he knew about recovered non-human craft. These dramatic claims attracted attention from all over the world, but they lacked crucial, verifiable proof. NASA ordered a thorough investigation of unidentified anomalous phenomena, or UAPs as they are now known, in response to the public's growing curiosity. Their report from September 2023 came to a definitive conclusion. There is no proof that UAPs originate from other planets. The paper, however, recommended for more rigorous scientific approaches to data collection and acknowledged that many occurrences remain unexplained. AI is revolutionizing the field here. NASA revealed intentions to use enhanced sensor networks and machine learning techniques to examine UAP reports in the future, in order to quickly categorize known phenomena, aircraft, drones, weather balloons, atmospheric impacts, and isolate truly abnormal events for additional research. Several methods are being developed. Harvard astronomer Avi Lowe's Galileo project, which is implementing AI-powered detection systems all across the world, is arguably the most ambitious endeavor. These installations integrate radar arrays, infrared cameras, telescopes, and audio sensors, all of which provide data to advanced neural networks that are trained to identify and weed out common things. The method used by the Galileo mission is surprisingly scientific. Instead of making assumptions about what UAPs are or are not, let's use the greatest technologies to collect high-quality data. According to Lowe, we're looking at objects in and around the Earth's atmosphere, using AI to weed out anything that can be identified, and then looking through the remaining data to see if anything has unusual features. This method differs from earlier UFO investigations because it combines AI analysis with ongoing monitoring. Cameras and human observers can be deceiving, but machine learning processed multi-sensor arrays offer previously unattainable levels of verification. These attempts are based on a simple hypothesis. AI-powered detection networks would be our best chance to document alien probes with scientific rigor if they are visiting Earth, which is a significant possibility that has not yet been confirmed. The most extreme scenario. Leading scientists have come up with a profound and startling prospect as we continue our hunt for extraterrestrial intelligence. In addition to being our best chance of discovering extraterrestrial life, artificial intelligence may also be the most likely form that highly developed alien civilizations will choose. This idea contradicts our conventional perception of extraterrestrial life. Although they might have a different biochemistry, we have always thought of aliens as biological beings that are organic life forms that have evolved through natural selection. However, a different image is presented when we look at truly ancient civilizations, which could be millions or even billions of years older than our own. According to a number of well-known experts, artificial intelligence may be the logical evolutionary successor to biological intelligence for both humanity and any extraterrestrial civilizations. According to Oxford philosopher Nick Bostenram, a post-biological stage of evolution will result from a sophisticated civilization's development of artificial intelligence that finally outsmarts its creators. AI programs like Google's Gemini or sophisticated language models may be essential to deciphering any messages from the stars that humans may eventually receive. Even with small sample sizes, these systems are excellent at identifying patterns and drawing conclusions. Precisely the abilities required to decipher an extraterrestrial signal in the absence of a common language or cultural background. By applying AI to analyze and comprehend dolphin communication, complex vocalizations from one of the most intelligent non-human animals on Earth, researchers are already putting this strategy to the test. Our algorithms are trained to identify the structure and patterns of unknown communication systems by using this as a test run for possible extraterrestrial languages. The ramifications are intriguing. We may be developing the very technology that will enable us to interact with non-human intelligence in the future. Human and alien thought processes that could otherwise be completely incomprehensible to one another could be translated by our AI. As a result, a timeline with 3 successive responsibilities for AI is created. Initially as our search instrument, subsequently as our interpreter in the event of contact, and possibly as humanity's evolutionary heir who carries on the cosmic dialogue long after biological people have vanished. It's a viewpoint that fundamentally alters our understanding of the cosmos and the heritage of human civilization. What is the current state of our quest for proof that we are not alone? Has Google's AI discovered extraterrestrial life? The truthful response is no, not quite yet. Follow-up observations were unable to detect those 8 radio emissions that meet the requirements for technosignatures. It is now believed that magnetars are the source of the enigmatic fast radio bursts that AI detected. Neutron stars having strong magnetic fields that are extremely dense. Although they are real, the exoplanets found with Google's assistance haven't demonstrated clear evidence of life. However, our cosmic pursuit has undergone a significant shift. Although Google's AI hasn't discovered extraterrestrial life, it is identifying the signs, trends, and irregularities that humans once overlooked. It's broadening our perspective and bringing to light previously hidden facets of the cosmos. Astronomy as a whole is undergoing this change. AI is now a key component of astrobiology and cities, from radio bursts to secret planets to the chemical traces of far-off atmospheres. The most comprehensive spectra of exoplanet atmospheres are now being gathered by the James Webb Space Telescope. And in order to analyze this deluge of data, machine learning algorithms are crucial. They're looking for gas mixtures that could point to biological activity, such as oxygen and methane. Combined, the search is only getting started, even though no verified biosignatures have surfaced yet. In the future, artificial intelligence, AI, may be able to hear the message before humans do, and our digital products may be able to identify the minute patterns in the transmissions of a different civilization that human analysts would miss. It's possible that an AI system identifying an anomaly with a straightforward alert will make the next big discovery rather than a human scientist breaking the news. Human accomplishment is not diminished by this. After all, we created these AIs. Instead, it broadens our cognitive horizons beyond what our biological brains are capable of. AI may ultimately enable us to listen to the larger galactic discussion if the universe is full with signals that we haven't been able to detect. Are we alone, I wonder? It's still unresolved. However, the instruments we're creating to tackle it are more potent than ever before. More of the universe is scanned by our AI systems every day, with more intelligence and sensitivity than all of the earlier SETI operations put together. We've never been in a better position to hear someone who is attempting to reach us. You won't want to miss our next video if you thought this examination of how Google's AI is transforming our hunt for extraterrestrial intelligence was fascinating. We'll be delving deeply into the most recent findings from the James Webb Space Telescope and the ways artificial intelligence is assisting researchers in finding possible biosignatures on far-off exoplanets. The distinction between science fact and science fiction is becoming increasingly hazy. Additionally, we're dedicated to providing you with the most recent advancements as they occur. We'll be here to dissect everything, whether it's cutting-edge AI applications, enigmatic cosmic signals, or the upcoming space adventure. To be the first to know when we publish new material, subscribe and enable alerts. Come along with our group of inquisitive thinkers as we continue to investigate the universe's biggest mysteries and the amazing technologies that are assisting in their resolution. We're coming closer to discovering the truth, thanks to resources like Google's artificial intelligence.